Welcome to figuring out how to program variables and functions. This is definitely the advanced concept for programming, but it allows you to do some really cool stuff. So let's take a look. A variable is a space in your robot's memory where data can be stored. It includes whole numbers, decimal numbers, and words. So you're going to write programs that include variables, and generally we're going to just store whole numbers, 1, 2, 3, and we're going to have them count. Variable names follow the same rules as custom motors and sensor names, capital spelling, availability, so you have to make sure you spell it the same every time. And it can improve readability and expandability, so we'll show you how. So if you choose a variable, you can name it whatever you want. So in this example, they've named it cleared, and it is an integer. An integer just means it's a whole number. So we have declared this integer, we've called it cleared, and we've set it equal to a value of 0. And now we are saying that sensor value write encoder, so we put the sensor value name encoder, equals cleared. So what is the write encoder value set to right now? 0, because it's set to cleared, and cleared is 0. So that's one way you can use it. If you want to set a lot of variables, a lot of sensors to a certain value, and then you want those sensors to change, I'm going to show you how you can do that with these variables. So this little table just shows what different data types there are: ints, floating points, Boolean, character, strings. You can pause this and take a look at it if you have interest for this, but right now we're just going to be using code int. And this shows you how you would actually code those: float, bool, char, and string, or char, however you want to say that. And I have had students that have used different codes besides int as they got more advanced and interested in this, so you can come back to this and take a look at it. So if we're going to create a variable, you first have to give it a type. We're going to give this type int, then we name it. So we're going to call it rotations. So rotations would be a good one if you're talking about some type of the quad encoder, the thing that is, counts how many rotations around. So you can set the variable to different values, and whatever you give it initially is called initializing the variable. So if we say int rotations, semicolon, to the next line, and then we say rotations equals 4. So right now we're setting it equal to whatever that means, with just the number 4. Now, we'll get back to actually what that means. Right now we're going to look at a global or local variable. Global variable is set outside of the task main, and any function, which we haven't talked about yet, but any function can access a global variable. A local variable, which is typically what you're going to be using, is set inside task main. So take a minute, pause this, and read through the differences between global and local. So here's an example of a local variable, and if you want to go back to look at that definition, you can always rewind this. A local variable declares it within the curly braces of task main or one of your functions. You can only change the variable or the value of this variable within the task or function. And right now we've only looked at one task and function, so it's not going to make too much sense yet, but you might want to come back to this and take a look at it after you've seen functions. So right now we have task main, and inside that we've declared a variable. We called it rotations. You could call it pig or french fry or whatever you want to call it, but we say rotations because it would make sense with what we're doing. We say it equals 0. And now we're going to start the motor, and we have an until here. Until rotations is your encoder. So until the number of rotations, and right here you've set it to rotations, you're doing it until this number. Usually you would set this to a number like 1 rotation, 2, or 3, but what we've done is we set it to the variable. So that means it's going to go how many rotations? Well, what does rotations equal? 2. Alright, so it's going to go around twice and then stop. Now we've reset rotations to 4. Whoops. And we are going to start in the opposite direction. You have a negative sign here until it looks like whatever this variable says, which is 4 rotations. So right now that doesn't look like, okay, right now it doesn't look like that is doing a whole lot to help us out, but I'm going to show you where you can make this really save you a lot of time and do some cool stuff with using letters as variables instead of just putting the number 4 in there. So we'll look at global variables first. Global variables are declaring that variable outside of task main. So we've said int rotations, we've declared the variable here, and now here is the addition of a function which uses the word void. So we're not going to deal with that too much. The only thing you need to know right now is just that a global variable is set outside of task main. You can see task main is way down here, And then you have this other weird thing in here, this void thing. We'll look at that next. So a function is grouping several lines of code together, and then you can reference this a lot of times in the task main. So if you have a repeating block of code that you're copying and pasting it multiple times, you probably want to set it up as a function, and some of your programs are going to end up doing that. So if you want to create a function where the LED is on if the bumper is pressed and off if it's released, then the first thing we have to do is make a function header, definition, and then where we call it. So if you want to come back to this and take a look at these three things, you can do that. But here's the example. First, we declare the function. So we're going to run, it's kind of like a mini program within the program. We're going to call this thing LED control, so you can see where the mouse pointer is. And to declare that, we have to write the word void. That just declares that you have a function that you're going to call, a mini program that you're going to call up. So we are going to call up this mini program called LED control. And I'm going to continue to call it a function. So we declare that we have a function. And now let's just look at this task main part right here. You have task main, then you have your open and close brace. So your entire code is right here. That's it. That's your code. While 1 equals 1, which means forever, run this loop, LED control. Well, what in the world is LED control? Up here it says LED control is a function. So while 1 is 1, you're going to run this thing. Well, we don't even know what LED control is. So now down here, we define function definition. We define what LED control is. So this is where you write your code. And so again, we say void LED control. You're probably not just going to remember, how you declare these things using the word voids and which ones have semicolon like the declaration does, but the definition doesn't. So you probably have to come back and look at this. So we actually define this down here. We put if sensor value bump switch is 1, so if the bump switch is pressed, turn on the LED. Else, which means if it's not, turn off the LED. And that's our function. So then up here, task main, while 1 is 1, run this function forever, which is calling this thing up down here. Function declarations, which is what we had, let me go back, which is what we have right here, this thing. Function declarations declare a function exists and indicates its name, and the declaration has to occur between the hashtag pragma statement and the task main. And you see, here's the hashtag pragma up here. That's the thing that configures all of your switches, and between task main, you can see the function is declared right in here. And so that's what it looks like. The function definitions define the actual code, so that's where you actually put the code. So here is the function definition. We write the same thing that we called it, and you could call it anything. You could call it void turtleneck if you want to call it that, which would probably make no sense, and then put in whatever code you have in here. Oops, I probably shouldn't click the button, it's probably kind of loud. And you're calling up the function inside task main. So you have your task main, and since we want to loop this so that it runs this function forever, if you only want to run it once, you wouldn't do a while 1 is 1 loop. But we want to run this function forever, so we do while 1 is 1 LED control. Now here's where this is great. You could say while 1 is 1 LED control, and then after that you could put something like start motor, wait 5 seconds, stop motor, and then you could say LED control again. So that you're rather than pasting all that code in there, all you have to do is type in one line that represents a huge chunk of code. That's it. So let's give it a try in the next assignment, and if you need to reference this back again, which you probably will, this slide right here is probably the most helpful because it shows you how to declare it, where you're going to put it to call it, and then how you actually define the function. Right on, let's do it.